Hello. So today we're going to answer the question, how can I gather reliable data for comparison? So before we were talking about gathering data using surveys and taking a sample size out of a population and just asking them questions and figuring out what it is they think or what it is we're measuring, whether it might be, like I said, heights, weights, something like that. That's easy for us to gather. However, a lot of the times, though, we might want to use data for comparison. For instance, does a certain drug help with heart disease? Or does this water taste better than tap water? And a lot of those things we can't typically just find out. And so we need to be able to run or gather data for that so we can compare the two different things that we're looking at. And so today what we're going to talk about is we're going to talk about two types of studies. And the first one we're going to go through is an experimental design study. So this is going to be our focus for the first part here, is this experimental design study. So the one question I have here is, can people tell the difference between tap water and bottled water? So a lot of people think that bottled water tastes better, it's cleaner, it doesn't have any of the pipes that water is running through, and a lot of people believe this. And so we're trying to figure out, can they actually do that? So how would we set something up in an experimental study to figure out if people actually can tell the difference between bottled and tapped water? So, first things first, in order to build an experimental study, we're going to have subjects. And so we're going to take people, so we're going to have a population. In this case, it's anybody who drinks water. So everyone. We'll just put everyone. And from that population, we're going to take a random sample. So we're going to perform our SRS, just a simple random sample, or we could do a stratified if we really wanted to. And that's going to give us our subjects. Okay, these are who we are going to be testing. So we go from a population, then we take an SRS of that population, and we get random test subjects, because we don't want anything to really bias this. We want just randomized results like we talked about before with surveys. The tricky part with this, though, is how do we do this test now? Well, we're going to do two different things. We're going to take an SRS of our test subjects, because we still want that randomness. And then we're going to take the rest of the people and put them in a different group. And this group, I'm going to give people tap water. And in this group, I'm going to give people bottled water. So I have these two groups of people that are getting different things. And then what I'm going to do is I'm going to have them taste the water and say, do you think this is tap or bottled? And see what their responses are. The key, though, is that they don't know which one is tap and which one is bottled. This is what we call a blind study. And that's where our subjects don't know what they get. Okay, so this is a blind study that we're doing. And then I'm going to record the results and say X amount of people thought this was tap water when it really was, and X amount of people thought this was bottled water when it really was. And then I'm going to compare those results and say, was there a clear difference? Did the people who got bottled water notice that it was actually bottled water more than the people who got tap water? And so what we're trying to do is we're trying to give people two different things and then discern if there's something that we can tell that allows them to make that difference. And you'll see these experimental studies done in drugs, for pharmaceuticals to see if pills work better for like a heart disease or a brain disorder or something like that. All these things are what we do in science to figure that out. Now, this was a very simple experiment, and the two things we want to point out here is that this we call our control group, okay? They get just the normal stuff, and that's a key thing. So our control group gets what we usually get. And then there's a treatment group, and they get what we're trying to study. So in this case, we were trying to study if bottled water tastes different. Well, for the treatment group, we gave them bottled water, even though they didn't know it, and we wanted to say, can you tell a difference? So that's the first big thing with experimental studies. The second big thing is we must use the SRS to choose the groups. So when we take our population, we take a random sample for our test subjects. Then we take another SRS to split them up into groups, because we don't want people to know where they're going, and we don't want to just pick people that we think would be good for this. We want it to be totally randomized so there's no bias. And then we make it a blind study. So that way people don't know what they are going to be getting. They just assume it's something and they're not quite sure. And that allows us to keep them in the dark so they're giving us true responses and there's no biases there. So this is our experimental design study, and I'm going to do it in another way here for a different type of experiment. So for this experiment, I want to see, is Tylenol effective against heart disease? Okay, so what I need to do is I need to set up an experiment for this. So my population is not just everyone now. My population is those that have a form of heart disease. So my population is people with heart disease. Then I'm going to take an SRS and find subjects, because I want them to be random. I don't want people that I choose. I want it always to be that randomized way. Then I'm going to give the subjects another SRS and split them into two groups. This group here is going to be our control. And our control, we're going to give them a placebo. And a placebo is just a fake pill. It's basically just a sugar pill. So it won't do anything to the body. Then I want to see, for my treatment, I'm going to give these people the Tylenol. And again, I don't know what's going to happen with this study. I'm just trying to see, is Tylenol good for heart disease, for treating heart disease? So now I've given some people a fake pill, and I've given some people Tylenol, and then I'm going to compare the results. And those results might be like a physical, where you're testing to see, did this person's heart condition get better, did it get worse, or did it stay the same? And if a lot of people stayed the same in the placebo and the Tylenol, then I'll know that that Tylenol's not really working. However, if the Tylenol makes people a lot better in the treatment group, then I have evidence that Tylenol might be a really good treatment for this. Or it could go the other way, that the treatment group's Tylenol caused it to get worse. Now I know that it possibly could be causing problems. But the big thing, again, is that this is a blind study because I gave people a fake pill. To the control. And people don't know if they're in the control or the treatment. They are just going through and given a pill. Only we know, the people that are doing the experiment, know exactly who's getting a Tylenol and who's getting a fake pill. So we really want to make sure that we're understanding here that, again, we have randomized groups that are chosen for the subjects, and then they're placed into control and treatment at random. We have a control group here. They're getting the placebo, and we're getting a treatment group here. And again, this is a blind study, so nobody knows what pill they got. So this all allows us to be able to figure out, is Tylenol effective against heart disease? And we'll have to do a whole bunch of comparing and looking at the results and seeing that it makes sense and that it works. Okay? The one thing we have to do, though, is, and I'm sure some of you may have already kind of thought about it, the conditions for both groups have to be identical. Meaning that, so I'm going to go back to the first example. What that means is the conditions for both groups have to be identical. So up on this one, let's say the bottled water was colder than tap water. Well, people might think that that tastes better because people like cold water. So if I gave cold water in the bottled water group and only gave warm water to the tap water group, they wouldn't be able to know whether or not that might skew the results or cause a bias, okay? Because they might think, oh, this is warm water, I don't think it's good, so it's got to be tap water. Whereas people that got cold water will be like, oh, this is really good, so it must be bottled water. So things like temperature, setting, where you're taking it, where you're putting that, and how you're giving it out, those are all things that we need to make sure are identical. So for like the Tylenol and the placebo, maybe we give them a little cup. Well, every cup better be the same, because even just a color or a size of a cup or any little thing can cause people to think something's wrong. So we need to make sure everything's identical with the control and the treatment, so there's no other outside factors that might cause a bias. The only thing we want to be different is the placebo and the Tylenol, or the bottled or the tap water. Once we have those things the same and nothing else is going to change the results, then we have an effective study of an experimental design to figure out if those results are going to work. So in recap, for our experimental design, we need a few things. One, we need an SRS to choose subjects. Then we're going to do an SRS to split the subjects into a control or treatment group. Then we perform the experiment with identical conditions, and hopefully it's blind if we're doing something that we don't want them to know about. And 4, then we compare our results to see if there's any statistical evidence that points to what we're trying to prove. And the easiest way to kind of do this experimental design is to make that flow chart that we were doing up here, to kind of show what it is you're doing and how you're going to prepare people and split them up into controls and treatments so that we can follow along and know that it's going to be statistically relevant. And that is how we do an experimental design in collecting that kind of data, which we can then start to look at and analyze and see what it is that it's telling us. And again, we don't know what it's going to tell us. We just want to see if there's some sort of impact or effect.